For this lesson, we'll be solving and writing systems of linear equations. Make sure you have paper, pencil, and calculator at the ready. There's going to be moments where I would ask y'all to work through the problem either on your own or with me while I explain everything in the video. So just be prepared to work and participate while watching. If you would like a copy of the slides that I'm using, I uploaded these into the course. Just go to the STAAR tutoring course and go to the content. You will see them under the live notes section. Okay, so the specific TEKS we're looking at for today's lesson for system of equations is A.5c. Solve systems of two linear equations with two variables for mathematical and real-world problems. And A.2i. Write systems of two linear equations given a table of values, a graph, and a verbal description. Today, these are the objectives for today. Today, I am learning about systems of equations so that I can write systems of equations and identify their solutions. I'll know I've got it when I can write systems of equations from data and graphically find the solution to a graph. So, quick review before we move on to the rest of the lesson. Which line are these points on? So I have a list of points here, 1, 2, -4, -2, -1, comma 4. Look at the points below and put a check in the box for the line that it is on. Points may be on just one or both lines. So since you can't put a check on this video, you're going to either mentally or physically on a piece of paper or through your notes that are provided, put a check mark for the line that these points are on. So either the red line that you see right here or the blue line. So if you would like to pause the video and try that now, go ahead and do so. Otherwise, I'm going to reveal the answer. Okay, 1, 2. The way we read these points is x, y. Therefore, the x value is 1. And then the y value is 2, which means that this lands on the blue line. -4, -2. Again, x, y. X means I'm going to the left, -4. And then I'm going to go down to the -2, which means this is on the red line. -1, 4. So -1 to the left and then up 4 on the y. And as we notice that on the red and blue line, this point is located at the intersection. So these land on both. This is what we call a solution. This solution is involving two different equations where they cross each other. So that's what we call the solution to the system of equations, where they're equal to each other at that particular moment. What is a system of equations? System of equations is two or more equations that share the same variables. And again, we call the solution to a system of equation the ordered pair, where they cross each other. Two graphs intersect. So before, the solution in the previous slide was -1, 4. That is the solution to this system of equations. Whereas the solution to here, where they cross, is 2, 3. Now, a system of equations doesn't always have a solution. There are two other scenarios that you may see when dealing with systems of equations. They could also have no solutions or infinite solutions. Now, the case for no solutions, you have two lines that are parallel to each other. They will never cross, never intersect. They are always just side by side, going at the same slope, the same rate in both directions. So this is a case of no solution. Now, infinite solutions means that when you do the math, they're actually the exact same line. They just may be in different forms here. So 2x minus y equals 4 is the exact same equation as 6x minus 3y equals 12. If we do the math, you will see, which we'll get to a little bit later. But either way, this is what we call infinite solutions, where they're the exact same line, meaning that every single part of this line, they are intersecting each other. They are crossing. And so we can list all those points infinitely, for indefinitely. So those are the two scenarios. Well, there's three scenarios: no solution, infinite solutions, and one solution. Okay, so we'll call this one solution. Three different scenarios for solutions with systems of equations. Now we're going to go through a series of problems talking about the solutions to these systems, starting with this one. After I ask each of these questions, I would like for y'all to pause the video and try this on your own. Take a guess as to whether this will be, or what the answer will be. Anyways, here we go. So here's the first one. How many solutions does this system of equation have? No solution, one solution, infinite solutions, or you're not sure. So again, pause the video, try this on your own. Otherwise, I will show y'all the answer in about 5 seconds. So this system has two lines, right here and right here. And notice the angles they're going, they will eventually intersect each other at a particular point. So this has one solution to the system. Okay, next question. What is the solution to the system of equations? So now I'm asking you, what is that point where it intersects, where the two lines intersect? Okay, so go ahead, pause the video, try this on your own. Otherwise, I'm going to give you all the answer in about 5 seconds. Okay, so the solution to the system of equations is where they intersect each other. You can see right here on this dot. That's where they intersect. Now, to label the coordinate or the ordered pair, the point of intersection, whatever, it is first the x and then the y. Notice the units that this is counting by. So notice how these two lines are already at 4, which means each line is worth 2 units. So this is 2, 4 to get directly underneath this line right here. And then we're going to go up 1, 2, 3, but notice we're still counting by 2's on the y-axis. So this is actually 2, 4, 6. 2, 4, 6. Making this answer 4, 6 right here. Another question. A system of linear equations is graphed on the grid. What is the solution to this system? So pause the video, see if you can figure it out. Otherwise, I'm going to give you all the answer in about 5 seconds. Solution to the system, again, is where they intersect, if they intersect at all, which I see about right here. So again, when we talk about the ordered pairs, it is x first, then y. So starting from the origin being 0, 0, this is the origin. We figure out how much we need to travel to be in line with this point right here. So on the x-axis, we have to go 1, 2, 3, 4, 5, so that we can get in line with that point on the x-axis. So -5 is our x value. On the y, we have to go 1, 2, 3, 4, 5, downward as well to get in line with the y value. So -5, -5 is our answer. Okay, another question. How many solutions does this system of equations have? Pause the video, try this problem on your own. Otherwise, I will give you all the answer in 5 seconds. Okay, so we have two lines that are parallel. What does parallel mean? That means they're side by side and will never intersect each other. Notice the distance between each part of this line does not change at all, seemingly. It looks like it's never going to cross if we were to carry these lines out all the way. if we draw them correctly, that is. So because they are parallel, because we don't see a point where they may intersect each other, there are no solutions. They're never going to cross each other. Next problem, how many solutions does this system of equations have? Pause the video, and I will give you all the answer in about 5 seconds after you've tried it. So, the solutions. Notice how we have two different lines. We have the red line, and then we have the blue line on top. Notice how they're the exact same line. Just one of them may be shorter than the other. But these arrows means they're going to overlap each other continuously, indefinitely. So the only thing that makes sense is infinite solutions, since they're the exact same line, always crossing each other throughout the line. They have an infinite amount of solutions. Now, I believe we have one more, and then we're going to move on to a different topic. What is the y value of the solution to the system of equations? So look for the solution. Look where it's at. What is the y value of the solution to the system? Go ahead, pause the video, and then I'm going to answer in about 5 seconds. Try this on your own. Okay, so the solution to the system, again, it's where these lines intersect each other, which is right here, -1, 2. What is the y value to that? -2. That's our answer. Okay, so now we're going to practice using our Desmos calculator, graphing these two equations and seeing if there is a solution or not. So we're going to run into scenarios where we have equations, but we don't have their graphs. We're going to need to graph them ourselves, put them in a form that's appropriate for graphing, and then figure out where the solution is from there. So if you can, please go to the Desmos calculator. I have the website right here. www.desmos.com/testing/Texas/graphing. It's important that y'all use this exact calculator because this is the calculator you're going to be using on the STAAR test. Excuse me. It has certain amount of functions that you're allowed to use for STAAR testing, whereas some of the other versions of Desmos calculator has a little bit more than you're allowed to use. So again, to practice our STAAR test, use this specific Desmos calculator. You'll know you'll have the right calculator when it says the STAAR version or EOC version, 8th grade, whatever, at the top. Texas. Okay, so let's practice using Desmos. Or actually, mine says grade 8 EOC math version. This is the STAAR test version of Desmos that we're going to be using. So, anyways, now to enter these equations, there's a couple ways. Y is the same as f of x, which we may get into later, but you can do f of x equals 3x plus 2, and then you'll see the line right there. Or you could just say y equals 3x plus 2. You'll get the exact same thing. And then you'll put one of these equations on the first line. Let's call this equation 1. And we'll call this one equation 2. So the first one, we already put it on the first line. Second one, do the same thing. Y equals negative 2x minus 3. Okay, and you should have two different lines on there. If you want to change the color, you can just click and hold the color right here, and then change them to whatever color you want. I'll change mine to just orange and blue. And you can click on each line, and it'll highlight certain things. So, for example, if you click on the blue line, notice how it'll highlight some points of interest, like the intersection, -1, -1. The x-intercept, which is -1.5, 0, and the y-intercept, which is 0, -3. So those are just some interesting points. Otherwise, you can just go through the line and find some nice points if you see they cross through a corner. on the grid. Same thing with the orange line. If you click on the orange line, you'll see some points of interest right here. And if you click on those points, they'll stay displayed for the most part until you start zooming out. Anyways, there you go. You can zoom in either using the mouse wheel or your plus and minus right here. You'll have extra settings that you can mess around with where you want the x-axis to be. So let's say we want for it to be between -20 and +20. And we want this to be -20 and +20. It'll arrange, it'll resize the grid to fit that those numbers, that range or domain, whatever. Okay. Otherwise, you could just click plus, minus to zoom in and out, or use the mouse wheel. Okay. But anyways, we graphed our two equations for our system, and to get the solution, all we do is just click on one of these lines and then look for the point where they intersect. So our solution for the system is -1, -1. Right here. So at this point, I would like for y'all to try and graph these two on your own and see if you can find a solution. And I will give y'all the answer in about 5-10 seconds of silence. So if you would like to go ahead and pause the video, try this on your own. Otherwise, I'm going to give y'all the answer in just a little bit. Enter this into Desmos for equation 1, equation 2, and then click on the intersection point, and then just have that ready for whenever I say it. Okay, so the first equation that we're going to enter into Desmos, y equals 2x minus 2. Second equation is -1 divided by 2. And then notice where your cursor is. We need to get out of there to the right. So we're going to arrow to the right. Oh, I forgot y equals. And then we're going to put an x after we've arrowed out of there, and then plus 8. And again, you can move the graph around however you want. Just make sure we can have that intersection point visible there. When you click on that point where they intersect, our solution is 4, 6. So again, the solution is 4, 6. And that is our intersection point. That is the solution to this system of equations. Now, we're not always going to have these equations in the form that's best fit for graphing, or at least for the calculator to graph it. So you may see it in a form called standard form. Standard form is ax plus by equals c, where a, b, and c are integers. Basically, all this says is x and y are on one side, and then the number without the letter, the constant, the c, is on the other. Okay, so for example, 3x plus 2y equals 8 is in standard form. In order for us to graph this, or at least to graph it using the graphing calculator, we need to solve for y. What does that mean, solving for y? Well, let's take a look. So again, we have the standard form of the equation, 3x plus 2y equals 8. And our goal is to get the y by itself. Well, how do we do that? Well, first thing I'm going to do, just to kind of organize my thoughts here, is going to draw a line, write down the equal sign to separate the left side from the right side. And now my goal, starting with the furthest thing away from the y, is to start moving things to the other side of the equation. So I want to move all of this to the other side. And it's going to be dependent on what sign that is. So I'm either going to add or subtract based on whether it is negative or positive, respectively. Now, in this case, notice how it's separated but attached through a positive, or possibly, you may see another type where it's attached with a negative sign. I'm going to have to determine whether this itself needs to be added or subtracted. This positive is attached to the 2, so I'm not going to touch that. I'm only going to look at what's next to this 3 on the left side. I don't see anything, so it's assumed to be a positive, which means I need to subtract 3x on both sides. So now that positive goes away, and this just becomes 2y equals this negative 3x cannot combine with 8 because they are not like terms. 8 and x are not related in the sense that they both do not have an x. So all what we can do is put negative 3x plus 8. Or you can do 8 minus 3x. However, I like to have the x out in the front, so I just rearranged it with negative 3 in the front, and then the 8 is positive, so negative 3x plus 8. They mean the exact same thing. Now, what's attached to this y is this 2, which is being multiplied to it. So the opposite of multiplication is division. I'm going to divide everything by 2. So negative 3 divided by 2, and then 8 divided by 2. The y will now be by itself. Negative 3 divided by 2, I'm not going to worry about it too much. I'm just going to leave it as a fraction with an x. 8 divided by 2 will turn into a plus 4. Now, this is something I can use Desmos to graph. So, just to show y'all what I mean, let's take out the Desmos calculator. I'm going to erase these things. And I'm going to type it in the form that you currently see it. 3x plus 2y equals 8. So it does not recognize the form that it's currently in, which is in standard form. So we needed to change it to its slope-intercept form, which is right here. So now I'm going to type that in. Y equals negative 3 divided by 2x plus 4. Yes, that's it. And this form, where y is by itself, is the appropriate form to graph equations. And that's it for this standard form right here. So that's the main thing that I wanted y'all to get, is that sometimes it's not already solved for y. You need to do the work, try to get y by itself, to then graph it. Now you see right here, here's another form, 8 minus 3x over 2. So that's just kind of simplifies some things here. So this is taking this form, 8 minus 3x, and then dividing it by 2, like we did right here, so that we don't have to worry about the orientation of it. This form right here, negative 3 over 2x plus 4, does have some benefits with knowing what the slope is going to be and what the y-intercept is going to be. This, however, can be acceptable as well to just graph. So it's up to y'all, how y'all want to do that. Okay, so now we're going to practice trying to get the y by itself. I have an equation right here, 8x minus 2y equals 6. I would like for y'all to make sure you have paper, pencil, calculator at the ready, or whatever, to try this problem on your own. I'm going to show y'all 2 different ways to get y by itself so that we can graph it into Desmos. Okay, so again, go ahead and pause the video, try this on your own. Otherwise, in about 5 seconds, I'm going to continue and show y'all 2 different ways on how to get the y by itself. So the first way to do this, to get y by itself, I'm going to subtract 8x on both sides. Whatever is the furthest away from the y is the thing I want to focus on the first, which is the x, in this case, the 8x. This is positive 8x. Notice that there's no sign to the left of the 8, so I'm going to just subtract 8x on both sides. Positive 8, negative 8 cancels, and I'm left with negative 2y. I'm going to arrange this to where the x is first, which is negative 8x plus 6, because the 6 is positive. Next thing I notice is this negative 2 that's attached to the y through multiplication. So I'm going to do the opposite of multiplication, which is divide both sides by -2. Now I'm going to divide everything by -2. So -8 divided by -2 and +6 divided by -2. Y would then equal, just to make sure y'all see this, -8 divided by -2 will be +4. And then +6 divided by -2 will be -3. So this will be 4x minus 3. And again, this form, this slope-intercept form, allows me to see the slope as 4 and then the y-intercept as -3. So this is the perks of having it in this form, the slope-intercept form. However, if you just want a graph, there's a different way we can go about it. So here's the second way y'all could have done this. Okay, so let's just subtract 8x on both sides. Let's not worry about where it's at. We're just going to have -2y equals 6 minus 8x. And then divide everything by -2. And that's it. Done. We don't have to rearrange, divide everything. We just leave it in that form and then go ahead and graph. So y equals 6 minus 8x divided by -2. Both will give you the exact same result. So let's take a look at graphing this on Desmos. I'm going to graph the first one. Y equals 4x minus 3. We have the purple line right here. And then I'm going to grab the second one right over here. Y equals 6 minus 8x divided by, I'm going to highlight the entire thing, and then I'm going to hit the division button, the slash, so that I can get the bar over under everything, and then divide by -2. And notice when I switch these lines out, it's the exact same line. Okay, so either one is appropriate. However, the slope-intercept form provides some other information about slope and y-intercept if you need it. Okay, so that's this example. Another example for y'all to try, 3x minus 6y equals 18. So again, if you would like, go ahead, pause the video, try and get the y by itself. I'm going to again, show y'all two different ways of how to get the y by itself. Okay, so again, pause the video, try this on your own. Otherwise, in about 5 seconds, I'm going to show y'all how to do how to get the y by itself two different ways. Okay, so to get the y by itself, we got to get the furthest thing away from it to the other side of the equal sign. How do I do that? Whatever's attached to it, I'm going to do the opposite, okay? And we could do this because it's separated with addition or subtraction. Anytime we have addition or subtraction separating the two, we can move it using addition or subtraction. In this case, I'm going to subtract 3x from both sides because I notice that the 3 itself is positive. So the opposite of positive is negative. That -6 gets attached to the y. In this way, I'm going to have -3x plus 18, where the x is first. Then I'm going to divide both sides by -6. Divide everything by -6. So -3 divided by -6 and 18 divided by -6. And now y will equal, that should be 1/2, but I'm going to show y'all using Desmos. -3 divided by -6 is +0.5 or 1/2. You can change from decimal to fraction by clicking this circle button right here. I'm going to want it as a fraction. So I'm going to leave it as 1/2. Sometimes you may see the answer as a decimal. Sometimes you may see it as a fraction. Unless otherwise noted, I usually like to keep things as a fraction. So 1/2 x, and then 18 divided by -6 should be -3. But again, I'm going to show you on the calculator. 18 divided by -6 is equal to -3. So this is -3. And this is the slope-intercept form. 1/2, rise over run. The slope is 1/2. And then the y-intercept is -3. The other way, where we just want to graph it, we don't care about the features of the slope-intercept form. Subtract 3x on both sides. Let me move this graph a little bit more to the left. There we go. These will cancel. I have -6y is equal to, I'm just going to put it to the right of the 18. So this is 18 minus 3x. And then divide both sides by -6, and that's it. Y is equal to 18 minus 3x divided by -6. So on your Desmos calculator, again, it doesn't matter which version you have. We have, they're both the exact same line. So just to show y'all, I'm going to use the first equation. Y equals 1 divided by 2, and I'm going to arrow to the right, x minus 3. So that's one line, and then I'm going to show you the other line here. Y equals 18 minus 3x. I'm going to highlight everything, hit the divide symbol, the slash, and then divided by -6. I'm going to turn off and on the line just to show y'all that they're the exact same line. So it doesn't matter which one you want to use. I don't know if your solutions are going to be in this purple line. So I would be very wary about looking for solutions using this way. But it doesn't matter. You can still test out the lines by just putting them into Desmos and see if they match. So it doesn't matter too much. Just know what you're doing. This equation obviously has the benefit of the slope and the y-intercept clearly stated. So pick whichever. Okay, so now we're going to go over solving a system of equations where the equations are both in standard form that we need to then change into its slope-intercept form or into a form where we can easily graph them. So if you would like, I would like for y'all to pause the video, see if you could do this on your own. Get equation 1 and equation 2 with y by itself. So please do that at the moment. Otherwise, in about 5 seconds, I'm going to show y'all how to do this problem. Okay, so I'm going to put these two equations on a different slide with this, the first one going over here on the left and the second one going over here on the right. I'm going to do these relatively quickly to kind of show y'all like how this is supposed to go. So to get the y by itself, I'm going to subtract 10x on both sides. I'm going to get -2y equals -10x plus 24. Then divide both sides by -2. I'm going to get y is equal to, now everything on the right side is going to divide by -2. So -10 divided by -2 is positive 5x. 24 divided by -2 is -12. And then here is our slope-intercept form. Alternatively, you could have had y equals 24 minus 10x divided by -2. This would have given us the exact same equation. Either way is acceptable. The first one, obviously, you've heard me talk about the benefits. This is in slope-intercept form, and we have the slope right next to the x and the y-intercept at -12. Okay, now for the other equation. To get the y by itself, I'm going to subtract 6x on both sides. I'm going to have 2y is equal to negative 6x plus 8. Divide both sides by 2. And I have y equals, again, everything gets divided by 2, so that's negative 6 divided by 2 is negative 3x. Positive 8 divided by 2 is positive 4. And here's our second equation. Again, alternatively, we could have had y equals 8 minus 6x, all divided by 2, that you could have used to graph as well. Okay? So, either way, these are the two equations that I'm going to then put into Desmos. Starting with the first one, it doesn't matter the order, but starting with the first one that we solved, we have y equals 5x minus 12. And for the second one, we have y equals negative 3x plus 4. Go to the line and go to the point that you see where they intersect. We'll click on the line and go to the point where you see they intersect. Click on it so that the point stays displayed. And our solution for this system is going to be 2 comma negative 2. So again, 2 comma negative 2. Let me do that in a different color. 2 comma negative 2 is our solution to the system. Okay? So again, equation 1 on the left, equation 2 on the right, and then our solution 2 comma negative 2. Okay, so here's some more practice. We have another system of equations. This problem asks for what is the x value of the solution to the system of equations. So we have two equations, 1 and 2. And we got to make sure that both y's are by themselves. Okay, so at this moment, I'd like for y'all to pause the video, see if y'all can get the y by themselves for either equation, and then find the x value to the solution. Okay, otherwise, I'm going to go ahead and do the problem and show y'all the answer in about 5 seconds. So, if you notice, the second equation is already with y by itself, so there's nothing for me to do here. If you want to know what the line will look like, we graph it into Desmos. Let's do this on the second equation. Y equals negative 5. We'll notice that it is a straight line that goes left to right. Okay, so now all we need to do is look at the first equation and figure out what the equation is with y by itself. So again, I'm going to quickly show you two different ways to get the y by itself. We're going to subtract 6x on both sides. We're going to get positive 8y is equal to negative 6x minus 22. And then we're going to divide both sides by 8. So y is equal to, as a fraction, negative 6 divided by 8 will be negative 3 over 4. So I'm going to put negative 3 over 4x minus, and then, minus because this is negative divided by a positive. And then this will be negative 22 divided by 8, which as a reduced fraction, simplified fraction, is negative 11 over 4. Okay, so here's one way to get the equation. We have the slope and we have the y-intercept. The other way we could have done this is leave it exactly as it is, or just do the math, like leave it right here. We could have just graphed it that way. Or the other way, where we just put the negative 6x next to it and then divide it by positive 8. And then there we go. And so we would get the alternative form. Negative 22 minus 6x divided by 8. And we would just plug that into the graph. So now we're going to take Desmos and type that in. Either form, it does not matter. Negative 3 divided by 4 x with the y equals in front. You can get away with not putting y equals on some of these, but just to be safe, y equals negative 3 over 4x minus 11 over 4. And then I'm going to look for the intersection. So I'm going to click on the line, look at the point, click it where they intersect, and my solution should be 3 comma negative 5. However, this is asking for what is the x value of the solution. So going back, the x value to my solution should be positive 3. I believe there's a typo here. One of them maybe should be negative, but the answer should be positive 3 for this problem. Here's another problem. What is the value of y in the solution to this system of equations? Notice the systems and notice how they have different forms than the ones we've been practicing for. However, the goal is still the same. You still want to get the y by itself by moving everything that's not a y to the other side of the equal sign. So just try to think about that. See if you can figure this out on your own. Pause the video, work through this, try to get an answer. Otherwise, in about 5 seconds, I'm going to show y'all how to do this. Okay, starting with the first equation, 6y plus x is equal to negative 59. So I want to get the y by itself. Notice how the y, however, is over here first, and the x is next to it. Does not matter the order that these things are. The goal is still the same. We need to move the x first. Notice how this is positive x, so we have to subtract x from both sides. 6y is equal to negative x minus 59. And divide both sides by 6. So now y is equal to, that negative signifies there's a negative 1. 1 divided by 6 can't happen, so when you plug it into the calculator, you're just going to get negative 1 over 6x. 59 divided by 6, I believe, is going to be the same. Let's check just to make sure. Negative 59 divided by negative 6. Yep, does not, positive 6, which would change the fraction to a negative, so that should be negative 59 over 6. And here's the equation we're going to use to graph. And again, there's different forms that you can have this in. The other form that we've talked about could be y equals negative 59 minus x divided by 6. That could be the other form you use to graph this. Now, moving on to the second equation right here. X equals minus 2y plus 9. Goal is still the same. We still want to get the y by itself by moving everything to the other side. But notice how the x is already on the left side. Well, nothing changes. The y is still our focus. So now instead of focusing on the left side, we're going to just focus on the right side. We're going to move this 9 away to the x. So now we're going to subtract 9 on both sides, and we're going to get x minus 9 is equal to negative 2y. Then divide both sides by negative 2. And our answer, which I'm going to switch the y to the left now, is going to be x over, or negative x over 2, because this is going to be 1 divided by negative 2. And then we have negative 9 divided by negative 2, which is positive 9 over 2. The other form that we could have used in this case is just simply y equals x minus 9 divided by negative 2. And you'll get the exact same answer. Either one will give you what we need. Now, again, just pay attention to what we're looking at. we're looking for the y value of the solution to the system of equations. So keep that in mind as we're graphing these into Desmos. So let's start with the blue. We have y equals -1 divided by 6 x minus 59 divided by 6. Or we could have just put -59 minus x divided by 6. Same thing. Matter of fact, let's do that. Let's use the, or no, let's just keep it the same. We'll try to change it up too much. Y equals -1 divided by 6x minus 59 divided by 6. Now the second equation is going to be in the yellow. Y equals -1 over 2 x, or -x over 2 plus 9 divided by 2. So now zoom out if you have to. Look for that intersection point. Click on one of the lines, then look for that intersection point. Click on it. We want the y value to it, which means the -17 is our answer. So -17 is the y value of the solution to this system of equations. Here's another STAAR test question we may see. What is the x value of the solution to the system of equations? Again, just like with the previous problems, we have two different types of, two different equations. Notice how each one does not have the y by itself. So it's our job to get the y by itself so that we can use Desmos to graph them and then find their solution. However, we don't want just the solution. We want to find the x value of the solution. So I'm going to take this first equation off to the side. X equals 2y minus 4. And I'm going to get y by itself. Now, with one of the previous problems, notice how the x value is on one side and the y and the constant are on the other. The goal is still the same no matter what form or variation you see the equation in. We still want to get the y by itself, and then the furthest thing away from the y is what we want to get rid of first. Notice how the 4 is being subtracted. So we're going to add 4 both sides. Okay, you don't have to draw this line, but I like to draw the line to signify the left and the right. So on the left side we have x plus 4, and on the right side we have 2y. Now I'm going to divide everything by 2. And I'm going to show you one of two forms. The form, which I prefer, is slope-intercept form. X divided by 2 plus 4 divided by 2. Everything on the left side needs to be divided by 2. Now, if you don't see a number there, that's 1. So this is actually 1x divided by 2, which will be just, well, first off, let me put the y on the left side now. On the right side, I'm going to switch the orientation. This will be 1 over 2x plus 4 divided by 2, which is just 2. And again, this is the slope-intercept form. The slope is, the rise over run is 1 over 2, and the y-intercept is positive 2, meaning where it crosses on the y-axis. We could have used the other form, which you see right here. Y equals x plus 4 divided by 2 and be done with it, and then just graph it to get our answer. However, we do need to know what the slope-intercept form is. There are other problems that involve slope-intercept form, and we need to know how to distinguish when to use just the form to graph or the slope-intercept form. Either one is acceptable for graphing, although I would deem this a little bit more important. Okay, but either one, I'll show you all both whenever we get to it. Okay, so now with the other equation, we have something that we're used to seeing, or at least we were used to seeing at the beginning. 7x plus 5y equals -66. So to get the y by itself, I'm going to move the 7x to the other side by subtracting 7x. We have 5y equals, and I'm going to put the x in front, negative 7x, and then minus 66. I'm going to divide everything by 5. And I'm going to put it in slope-intercept form. Y equals negative 7 divided by 5. That cannot happen. So if I were to do negative 7 divided by 5, it gives me a nice decimal, but I usually like to keep it in fraction form unless otherwise noted. So negative 7 over 5 is what we have. And then negative 66 divided by 5, I don't believe that can be reduced, but we will check. So negative 66 divided by 5, and no, it stays the exact same fraction. So we're just going to leave it the way it is. Now the other form we could use just for graphing would have been y equals negative 66 minus 7x, or what you see right here. We just move the 7x to the other side in the opposite sign, divided by 5, and then done. And then we just graph it and get our answer. However, like I said many times at this point, this is the slope-intercept form. This tells me the slope, the rise over run, is negative 7 over 5, or 7 over negative 5, wherever you want to put the negative. And then the y-intercept is negative 66 over 5, which is about 13 actually. 13 point something. So the y-intercept is going to be at negative 13 point something on the y-axis. Okay. Now that we have the equations with y by itself, all we got to do is graph them. Starting with the yellow equation, I'm going to type in y equals 1 over 2 x plus 2. And then with the blue equation, I'm going to type in y equals negative 7 over 5 x minus 66 over 5. Okay, I'm going to zoom out on the graph, make sure I can get the intersection. Click on one of the lines, it doesn't matter. And then look for the point where they intersect, which is negative 8 comma negative 2. However, look at the problem. What is the x value of the solution? The x value of our solution will be negative 8. So this is our answer. Okay. Now let me show y'all how to do this, or show y'all these other two equations to show y'all that it's the exact same thing. It doesn't matter what form we use as long as we do the math to get those forms. Okay. So for example, negative 66 minus 7x with the y equals at the front. I'm going to highlight it, then divide by 5. That's the first equation, or second, doesn't matter. And then I'm going to type in y equals x plus 4. Again, highlight it, and then hit the division symbol, divide by 2. Now I'm going to look for that point again. And again, it's negative 8 comma negative 2. Negative 8 is the answer for this problem. Okay, so now we're going to shift into some word problems. So we're going to look at a word problem. We're going to identify the components to that word problem. We're going to build the equations that represent that word problem. And then we're going to solve for what the problem is asking for. Okay, so now this word problem is going to involve systems of equations. I'm going to hopefully show y'all how we can identify that this is talking about a system of equations. So let's read through the problem and then just start picking out some of the important information. Two customers went to the post office to buy postcards and large envelopes. Each postcard costs the same amount and each large envelope costs the same amount. Customer 1 paid $12 for 14 postcards and 5 large envelopes. Customer 2 paid for $24.80 for 10 postcards and 15 large envelopes. Excuse me. What was the cost in dollars of each large envelope? So, how can we tell that this is a system of equations? Well, we have the clue that there are two different customers that are buying postcards and large envelopes, two different things. We don't know what the price is for each one yet, but we do know the price for their totals. So each postcard costs the same amount and each large envelope costs the same amount. Again, we don't know what their cost is. So this is saying that postcards, we're going to choose one variable. We don't know what this is. We'll say postcard is X, and large envelopes will be Y. Again, we don't know. However, we do have the following information here. Okay, customer 1 paid $12 for 14 postcards and 5 large envelopes. And then we have customer 2 paid $24.80 for 10 postcards and 15 large envelopes. Okay, so one thing that I want to make a skill of is being able to translate the English to math. So starting with customer 1, how can I translate all of that English into a math equation? Well, customer 1 paid $12 for 14 postcards and 5 envelopes. So that means whatever he bought, we'll call this equation 1. Whatever he bought, it totaled $12. Now, what did he buy? He bought 14 postcards and 5 large envelopes. Now, 14 and 5, those are the total of postcards and envelopes, but we need it to equal to money. So what should X and Y represent in this case? X represents the cost of the postcards. Y represents the cost of the large envelopes. Okay, so this is 14 postcards, and then the X represents the cost of those 14 postcards, and then 5 large envelopes, and then Y represents the cost for each of those envelopes. So 14x plus 5y equals 12. That's the first equation. We're going to do the same thing with the second equation. We know that this person, customer 2, bought $24.80 worth of postcards and envelopes. Now, so what did he buy? He bought 10 postcards and 15 large envelopes. That "and" is a signifier for a plus symbol. So 14 plus something, 14x plus 5y. 10x plus 15y is equal to 2480. So now from here, we're going to try and solve the equation. Okay, so with either one, we need to get the y by itself. So now here starts the process of figuring out what the cost of each large envelope will be. And I'll just do these very quickly. I won't spend too much time talking about it. Okay. Let me create a different slide. Okay, so I've created, or I've put the two equations on a different slide to solve for either one. I'm going to go through these pretty quickly. So if you need to understand it, just rewind the video and go through it again. But anyways, trying to get the y by itself, I got to subtract the 14x to the other side. I get 5y is equal to negative 14x plus 12. And then divide everything by 5. And then I get y equals negative 14 over 5x, because 14 and 5 do not divide. And then plus 12 over 5, because 12 over 5 does not divide either. And then here's my first equation. And again, an alternative way we could have done this is y equals, subtract the 14 with the 12, we get 12 minus 14x. Divide everything by 5, and there we go. Easy way to graph. However, like I said before, sometimes we want the slope-intercept form. So that's a good skill to have to be able to go from the graphing form to go straight into Desmos to slope-intercept form. Okay, now going to the other equation, again, trying to get the y by itself, minus 10x both sides. We have 15y is equal to negative 10x plus 24.8. Divide everything by 15, and we have y equals negative, and then if we were to divide this, it would actually be negative 2 over 3. So let me show y'all using Desmos. Negative 10 divided by 15. Turn it into a fraction. That's negative 2 over 3. So negative 2 over 3x. 24.8 divided by 15, I believe, does not do anything. But I will check. 24.8 divided by 15, turn it into a fraction. Yeah, it just turns it into an even worse fraction, so I'm just going to leave it the way it is. It's a little improper, but I'll just leave it like that. Okay? Now, the other way we could have done this, to just graph it, in case y'all are doing these the other way that I've talked about, is take 24.8 minus 10x, and we get that exact thing, 24.8 minus 10x, all divided by 15 from over here. And then just graph that and then find your solution. Okay? So now we're going to take Desmos. We're going to graph these into the first and second line. So y equals negative 14 over 5x plus 12 over 5. And then we're going to get the second equation right below it. Y equals negative 2 over 3x, x plus 24.8 divided by 15. I'm going to look for their intersection. Click on one of the lines, look for where they cross, and then click the dots. Okay? So there's two things that I see. 0.35 and then 1.42. So I'm going to write this down just for the moment. Let's go back to the previous slide here. 0.35, comma 1.42, I believe is what we got. Yeah, 0.35, comma 1.42. Now, this is the x value, and this is the y value. Look at what the question is asking. What is the cost in dollars of each large envelope? Well, it doesn't tell us to get the x or get the y. So we have to interpret that from our word problem. What is large envelope? Large envelope is the y value. We have the solution. So what is the solution to this system? 1.42. Each envelope costs $1.42. So this is our answer for this word problem right here. Okay, here's a problem that y'all can try on your own. So if you want to attempt this problem, see if you can set it up. Notice how the question is, well, the answers are only the equations. So all it's asking you to do is to set up the equations and see which one is, well, if you can find the correct setup and choose the correct setup from the list of answers here, okay? So if you want to try it, see if you can figure it out on your own, go ahead. Otherwise, in about 5 seconds, I'm going to show y'all how to do this problem. So again, read through it, see if you can figure it out. Otherwise, I'm going to show y'all in about 5 seconds. Okay, so there are 15 plates in a kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. The diameter of all 15 plates combined is 140 inches. Okay? So, what system of equations can be used to find the number of 7-inch plates, x, and the number of 12-inch plates, y, that are in the cabinet? So, what do we know? How do we start this setup? Where do we go? Okay? Now, what I would advise y'all to do in a problem like this is to figure out what our totals are. Okay? So, we know there's going to be a system of equations, so we know we're going to have two different totals here. So we have a total. Here's one of our totals. Let me highlight this in a different color here. One of our totals is 15 plates. So we know 15 is going to go on one of these. We know another one of our totals is 140 inches. So that's going to go on one side of the equal sign as well. So one talks about plates, and then the other talks about diameter. We need to create equations that associate with plates and diameter. So, what's one of the equations that we have? Well, plates. We have two different plates, x 7-inch plates and 12-inch plates, y. So from here, it's just very straightforward. We have a certain number of 7-inch plates, certain number of y plates, put them together, and we have 15 plates. So x plus y is equal to 15 plates. Now, the other thing that gets talked about is diameter. That's where 7 and 12 come into play. So we have a combined total of 140 inches in diameter of plates. So how do we structure that? Well, the x, 7x, tells me the number of plates times 7 will give me the total number of inches in for diameters of x plates. And then we do the same thing with y. We have 12y to give us the total number of 12-inch diameter y plates. When we add those two together, we get 140 inches in diameter. So now let's look at the equations here. One of them needs to have x plus y. So if we look at the first one, that's okay so far because we have x plus y. However, I see these don't have x plus y, so this is no good. These do. Okay, so now let's go even further. X plus y equals 15. This one's equal to 140. This one's no good. This one's equal to 15, so that's good. This one's equal to 15, that's good. Okay, now let's look at the diameter equation. 7x plus 12y equals 140. So 7x plus 12y equals 140. This one's good. 12x plus 7y, no. So the only answer that makes sense for this system is the third one right here. Okay, here's another question involving system of equations. Again, go ahead and read it by yourself. See if you can practice and figure this out on your own. The only hint that I'm going to give y'all with creating these equations is first look for your totals. What totals do you have? And then after you've found your totals, start building your equations based on what those totals represent. Okay, so go ahead and try this on your own if you would like. Otherwise, in about 5 seconds, I'm going to show y'all how to work through this problem. Okay, so a bag contains 18 coins consisting of quarters and dimes. The total value of the coins is $2.85. Which system of equations can be used to determine the number of quarters, Q, and the number of dimes, D, in a bag? So what totals do we have from this word problem? We have a bag that has a total of 18 coins. What's our next total? We have a total value of $2.85. Okay, so we have one equation that involves coins and the other equation that involves money. So the equation that involves coins, well, we have a number of quarters, we have a number of dimes. All we know is that quarters and dimes will equal to 18 coins. Okay. Now, let's go through our equations. Let's not even worry about the next one. We can already eliminate some of these answers. Okay. Q plus 8 equals 18. That equation needs to be in our answer. So let's look at the first one. Q plus D equals 18. Good. Q plus D equals $2.85. No. Q plus D equals 18. Good. Q plus D equals $2.85. No. So we've already eliminated two of the questions. Now we need to get to the next one. Now we have that these quarters and dimes will total up to $2.85. So what else can we put with this equation to get $2.85? We have the number of quarters. We have the number of quarters plus the number of dimes, but that's just not enough. So what's not shown in here is what is the value of a quarter. A quarter is 25 cents. What is the value of a dime? The value of a dime is 10 cents. So 25 cents per quarter plus 10 cents per dime should total up to be about $2.85. Let's look at to see which one that will follow. 10 cents per quarter? No, this one doesn't make sense. So the only one that does is this third one right here. Okay, that's it for this problem. Okay, this next problem is even more vague compared to the rest because it gives us just a few things to go off of, and then we need to build the rest of it to get an answer. Okay, so again, if you would like to, I would like for y'all to pause this video, try this on your own. This is a system of equations problem. However, the hint is not always going to be there. So see if you can identify why this is a system of equations problem, and then proceed to find the answer. How many courses are worth 3 credits? How many courses worth 3 credits did this student complete? So go ahead and pause the video. See if you can figure this out on your own. Otherwise, in about 5 seconds, I'm going to show y'all how to do this. All right, so a college student completed some courses that are worth 3 credits and then some courses that are worth 4 credits. The student earned a total of 59 credits after completing a total of 18 courses. So here we have our two totals. Two different totals usually means we have a system, okay? And two different types of things also means we have a system. Now, we need to figure out what we're going to call these things. So we're going to call 3 credits, the 3 credit courses, that's one thing. That's X. X equals 3 credit courses. And then we'll call the Y value the 4 credit courses. Okay? So now we have two totals. We have 59 credits, a total of 59 credits. And then we also have a total of 18 courses. It's important that you know what is associated with each total. That's going to help us with building the equation. Now, the one with the credits, the one with the courses, 18 courses. Well, we know we have some 3 credit courses. We have some 4 credit courses. There's no other qualifier other than those courses plus the other courses are going to total 18 courses. So X plus Y will equal 18 courses. Now, the other one involves credits. So we're going to have something else with the X and the Y. X represents 3 credit courses. So 3X, 3 times each X, which is each 3 credit course, plus 4 credit courses, which is 4 times Y. 4 credits per 4 credit course, per each of those types of courses, which should total up to 59 credits. Now, again, this is a little bit more involved because we need to find out how many 3-credit courses did the student complete. Or let me highlight the little bit better. Courses worth 3 credits. So we're going to have to get the y by itself and graph these into Desmos to find that 3-credit course, or how many courses that were worth 3 credits. Okay, so I've put the 2 equations on a different slide, and we're just going to work through them and try to get the y by itself. I'm going to start with the second one, actually, because it's very easy. To get the y by itself, subtract the x to the other side, and we get y equals, you can do this one of 2 ways, negative x plus 18, or y equals 18 minus x. Same exact thing, doesn't matter. I just tend to like the slope intercept form more because it tells me more information. Either way is fine. The other equation, 3x plus 4y equals 59, is a little bit more involved, but still the same procedure. You always start with the variable, the thing furthest away from the y. And distance-wise, that's the 3x. So we're going to subtract 3x on both sides. And we get 4y equals negative 3x plus 59. I'm now going to divide everything by 4 over here on the right side. And I have y equals negative 3 over 4x. Because 3 divided by 4, you can't actually do anything. I'll show y'all on the Desmos calculator. Negative 3 divided by 4 will give me a decimal, which I'm just going to leave as a fraction. And then I believe 59 divided by 4 is going to be the same thing. So 59 divided by 4, 59 divided by 4, same thing, gives me a decimal. I'm just going to leave it as a fraction. So this is just positive 59 divided by 4. Okay, or what we could have done is take 59 minus 3x and put it exactly as we see it right there, and then divide everything by 4 and just plug it into the calculator. Either way is fine. So now, take the Desmos calculator. I'm going to type in this equation here. Y equals negative 3 divided by 4 x plus 59 divided by 4. Then I'm going to type in the other one. Y equals negative x plus 18. Okay, I don't see my graph, so I'm going to zoom out until I do. Okay, and then zoom into that intersection here. I'm going to click on one of the lines. I'm going to look for that intersection point, 13, 5. Now, this is a part of my answer. Okay, so I'm going to go back. I'm going to jot this down, 13, 5. Okay, now 13 is my x value, 5 is my y value. So it's asking for how many courses are worth 3 credits. Which variable is 3 credits? Is that the x or is that the y? It is the x. So it's asking for the x value as my answer, which means 13 is the final answer for this problem. Okay, that's it for this question. Okay, so now we're going to go through different types of problems that involve our knowledge of systems of equations. So we're going to need to have a good grasp of what system of equations are, what the important points are, how to find the equations to graph, etc., and use it for this problem. So the system of equations is graphed on the grid. Which system of equations is best represented by the graph? So we have a graph. We need to figure out which of these equations best represents this graph. So there's a few things you could do, but I'm going to see if you could figure it out on your own first. So if you would like to try this on your own, see if you can find out what to focus on to find the right equations, please do so. So go ahead and pause the video, try this on your own. Otherwise, in about 5 seconds, I'm going to show y'all the answer and how to do this. Okay, so we have a system of equations on the grid, meaning this graph over here. So let's look at the graph. We need to find some interesting points. Well, one of those interesting points should be the solution. So that solution, which if we count 1, 2, 3, 4, 5, is -5, comma, and then right here, -5. So we know that our solution is -5, comma, -5. Well, one of the things that we could do is graph each of these and see if we get the exact same solution. So let's go ahead and do that. We're going to do this by process of elimination, because we know the solution should be right here. So let's start with the first set of equations. We're going to start with this. Y equals 2 over 5x minus 8. And then we have -3. Well, I'm sorry. Y equals -3 over 5x minus 3. Uh-oh. Okay, I forgot to go to this line right here. Y equals -3 over 5x minus 3. Okay, so I'm going to look to see if I have that solution, and right off the bat, I notice the graph doesn't match, so I don't even have to worry about the solution. That solution is in the bottom left quadrant, quadrant 3, I believe, and the solution for the first set of equations that I just put is in quadrant 4. So this one, no good. Let's do the other set right here. So again, I'm going to type in, let's do this right here. This first equation, y equals 5 divided by 2x minus 8. And then y equals -5 divided by 3x minus 3. And again, I noticed that the quadrant, it's in quadrant 4 to the bottom right, so this is not my solution. Let's try the next set of equations. Y equals 2 divided by 5x, minus 3. And then y equals -3 divided by 5x minus 8. Okay, there's some progress here. It's in the bottom left quadrant, so let's check to see what that solution is. I'm going to click on the line, click on the dots, -5, comma, -5. Okay, so this so far is our best bet, but we're going to check the other one just to make sure. So now for this last one right over here, we're going to type in y equals 5 divided by 2x minus 3, and y equals -5 divided by 3x minus 8. Okay, so it's in the bottom left quadrant, but let's check to make sure the solution is what it should be, and it's not. It's -1.2, comma, -6. So the only one that makes sense is this bottom left set of equations. Again, we identified the solution, and then we compared each of these graphs to the solution. Okay, now otherwise, if they had the same solutions, we would have to check the slopes. We would have to check the same y-intercepts for each of these, x-intercepts, all that stuff. Okay, but I chose the intersection, the solution, because that was the most easily identifiable part of the equations. And if they had the same slopes, or I'm sorry, the same solutions, then you would go a step further and look at the slopes, look at the y-intercepts to see if they all match. Okay, but anyways, that's it for this problem. Okay, another question where it asks for us to identify which set of system of equations does the graph represent. So using our knowledge for system of equations, see if you can figure out which of these which of these systems is the appropriate system for the graph that's being represented on the screen here. Okay, so go ahead and pause the video, see if you could figure that out on your own. Otherwise, I'm going to show y'all in about 5 seconds how to do this problem. All right, so the easiest thing that I could think of is let's use our tools. Let's use Desmos to see if we can figure out which one matches. I'm not even going to worry about the points right now. I'm just going to see if I can find one that matches that grid here. So let's look at the first set. Y equals negative x minus 4. And then y equals 2x minus 2. Okay? So look at the solution. Look at where it's generally located. It's in quadrant 2. Here's 1, 2, 3, 4 in a counterclockwise motion. Quadrant 2 is where the solution is at. If I look at mine, my first set of equations, quadrant 3 is where the solution is. So first set, no good. Let's start the next one. So the next one is negative x plus 4. And then the other one is 2x minus 4. Okay, that's again, in the first quadrant is where the solution is at, which is not what the graph shows. So the second set, no good. Let's start going to over here. This is x minus 4, and then this other one is negative 2x minus 2. Okay, it's in the fourth quadrant now, the solution, which is not representative of the graph that is shown here. So this last one is this next one is no good. By process of elimination, this should be the answer, but let's just check to make sure. It looks like it. So this next one should be x plus 4, and then negative 2x minus 4. And right here is where the solution is at, which matches this point right here. We could look for some other points if we want. Negative 1, 3. We can see if we have it. Let's zoom in. Negative 1, 3. Looks like we have a point right there. 1, 5. We also have a point right there too. Some other points that we can go for the second line right here, the one that goes from left to right down. Negative 4, 4, which we do right here. Should be right there. Yep. And then negative 1, negative 2, just to be sure. Yep, it's right there too. So the only one that makes sense for this problem is this last one right here. Okay, now we have a different type of problem where it's still a system of equations. However, they're represented by two different things. One of the lines, one of the equations, is represented by a graph of the line, while the other is represented by a table of values. So now from that graph and from that table, we need to then figure out which set of equations, which system best represents each one. There's different ways to tackle this. I'm going to show y'all maybe just a few ways on how to do this. But anyways, here we go. So again, a system of linear equations is represented by line D and line T. A table representing some points on line D and a graph of line T are shown. Which system of equations is best represented by lines D and T? So there's two ways to go about this here. Okay, one is using our knowledge of slope-intercept form. So let's look at line T here. And we could do this one of two ways. We can create an equation based on that line by just identifying a few points, or we can look at the slope and the y-intercept. So knowing y, let me change the thickness of that. So y equals mx plus b, where b is the y-intercept wherever it crosses on the y-axis. which will be 3 in this case. And then m is the rise over run, the slope. So starting from one nice point going to the next nice point, what is my slope going to be? Well, my rise is actually going 1, 2, 3 down, and then over 1. -3 over 1, which is just -3. Therefore, my equation for line T is going to be y equals -3x plus 3. Let's say we couldn't just figure out the slope at all. We know that the equation, one of these equations needs to have 3 for the y-intercept. So now let's look at our set of equations. We need it to be positive 3. So if we look, we have positive 3 here. That's good. Positive 3, -3. That's no good. So we can already eliminate one of these problems, one of these answer choices, by just knowing that the y-intercept has to be positive 3. Okay? Or actually, there's still a positive 3 over here. So no, we can't eliminate anything yet, but it was a nice try. Anyways, so one of our equations from the slope is -3x plus 3. So now let's look at one of these equations. -3x plus 3, I don't see it here. -3x plus 3, I don't see it here. I do see it here, but not here. Okay, and there we go. We didn't even have to use the table. I'm going to show y'all how to use the table anyways, but we eliminated all the answer choices based on our slope intercept form knowledge of line T. Let's say we didn't know how to do that. Let's instead use Desmos to figure out what the equation is for this table right here. So we're going to type into Desmos, the table, and then we're going to use the following. y1 squiggly mx1 plus b. I'll show you how to do this in a little bit. For right now, we're just going to enter the table into Desmos. So let's go to Desmos. Let's create a table. So in order for you to create a table, highlight one of the lines and then hit the plus symbol and click on table. And then we're going to enter all the x's and all the y's for that table. So -7, -4, 1, and 8. And then for the y values, -7 has -1.5, 0, 2.5, and 6. Okay, now on the second line, this is where this equation will come into play. You're going to have this memorized in order to use this table, or in order to create the equation using the table on Desmos. So you're going to type in y1. You're going to look for the squiggle symbol, which is next to the 1 on your keyboard. It should look like, if I go to this right here, this should look like this squiggle symbol next to the 1. You're going to have to hold shift and press that symbol, or just go to the keyboard right here under Desmos and then click on that symbol right there. Okay? Now typing in the rest, mx1 plus b. And what this is taking, it's taking the y1 from the table and the x1 and creating an equation. M is 0.5 and then the b is 2. So now, using all of that, we're going to create our equation. Y equals, m gets turned into 0.5, x, and then b gets turned into positive 2. What is 0.5 as a fraction? Because notice how none of these are decimals. So let's change the decimal back into a fraction. Let's go to line 3. Let's enter 0.5 as a decimal. Click this symbol to turn into a fraction, and we have 1/2. So y equals 1 over 2x plus 2. Now the only one that has that equation is the one we just circled right here. So there are the two equations that we need to answer this problem. Whichever way you want to tackle this is fine, as long as you're able to eliminate the wrong answers and then choose the correct one. So that's how you do a problem like this. Okay, now we have another problem where we have tables instead of lines or equations. So we're going to have to create the equations, and then notice how in this case we have them in standard form instead of in y equals mx plus b form, slope-intercept form. These are in the form of ax plus by equals c, standard form. Okay, so you're going to have to figure out how we know which of these answers is correct. Okay, so if you would like to try that on your own, I would like for y'all to pause the video, see if you can figure it out on your own, especially based off of what I just showed you here using Desmos. See if you can figure this out on your own. Otherwise, in about 5 seconds, I'm going to show y'all what to do. Okay, so for line Q, I'm going to create the equation. First, I'm going to make the table by clicking the plus sign and then the table, and then entering these values: -9, -3, and 2. And then with -9, we have 0. With -3, we have 18, and then we have 33 with 2. Okay, so now I'm going to type in the following: y1 squiggly, which you can find the squiggly next to the 1 button by holding shift squiggle, or by going on the keyboard right here, clicking on ABC, and then seeing the squiggle right there. I think it's called tilde, I'm not sure, but squiggle is what we need. And then you're going to type in mx1 plus b. And here's my equation. M is 3, b is 27. So based off of that, we're going to replace the m and the b. M is 3, b is 27. So for this one, y equals 3x plus 27. So there's our first equation. Okay, now for the second one, for line V, we're going to go back to Desmos. I'm going to enter different values for x and y. So x is -4. I'm going to erase these. So this should be -4, 0, and 10. And then we have, for -4, we have 10, 8, and 3. And then for this equation, we only have to type it in once. You could just leave it there for the rest of the time, and it'll autofill as long as you're using the exact same table. So now I'm going to look over here and notice the m value is -0.5, and then the b value is 8. So y equals -0.5 x plus 8. What is -0.5? Well, that could be a fraction, but we're going to leave it the way it is for right now. Okay. Now, if you look over here on the left, notice how none of them are in the slope-intercept forms that we just used. So I'm going to rewrite this again. We need y, let me use this in a different color here. Y equals 3x plus 27. And we need y equals -0.5x plus 8. So we need those two equations. Yep. However, None of these equations are in the correct form, so we're going to go through them and see if we can find the correct form here. Okay, an easy way you can think about this, well, no, I'll just save it. I'll save it here. So there's two ways we can go about this. Well, there's multiple ways, but let me just show y'all the way that I see the easiest. Okay, so right here, I'm just going to start getting y by itself. So to get 21x minus y equals 9 with y by itself, I'm going to subtract the 21x to both sides. I have negative y is equal to negative 21x plus 9. I'm going to divide everything by negative 1. Negative 21 divided by negative 1 is just 21x. And then looking at what I have here, none of the x's match. So this one, no good. Okay, now I'm going to move on to the next one. Okay, I'm going to start with this equation here. 3x minus y equals negative 27. So I'm going to subtract the 3x to the other side, minus 3x. I have negative y is equal to negative 3x minus 27. I'm going to divide by a negative 1. And I have y is equal to negative 3 divided by negative 1, which is 3x, which I have something there. And then I have positive 27, so plus 27. That's good. Okay, so now I'm going to try the next equation now that I've confirmed that this matches one of my equations. So let's try the next one now. So now let's look at the next one. I have x plus 2y equals 16. To get the y by itself, I'm going to subtract x on both sides. I have 2y is equal to negative x plus 16. I'm going to divide everything by 2. So that's negative 1 divided by 2. And then 16 divided by 2. 16 divided by 2 is going to be positive 8. Negative 1 divided by 2. Since I have a decimal in one of my answers, I'm going to go ahead and put it in decimal form. So negative 1 divided by 2 is negative 0.5. Okay, we found our match. Negative 0.5x. And there we go. So this so far is my answer, but I'm going to go through the rest of them and show y'all to make sure that this is our answer. Let's say we haven't found our answer yet. We're going to go to the next one and check it out. Just to double check, make sure everything is good. Whoops. No, let's go back here. All right, so 21x minus y equals 9. I'm going to subtract 21x minus 21x. I have negative y is equal to negative 21x plus 9. I'm then going to divide by a negative 1. Divide everything by a negative 1. Y equals negative 21 divided by negative 1 is positive 21x. And I can just stop right there because neither of my x's have negative 21 at all. So this one's no good again. Let's go to the last one now. (9x minus y equals negative 27). So now, again, trying to get the y by itself, I'm going to subtract 9x from both sides. Negative y is equal to negative 9x minus 27. Divide both sides by negative 1. Y is equal to Negative 9 divided by negative 1, if you type that into the calculator, is positive 9x. Again, I can just stop right here because neither of my x values have a 9x. So this is not the correct answer. And therefore, the second choice, the one that we found earlier, is the correct answer. So this is just an example of one way you can figure out what the answer is using Desmos. And again, I'll write the equation again. Y1 squiggly mx1 plus b. This is what you're going to type into Desmos. It's not available, so you're going to have to memorize this. After you create the table, you're then going to have to type in y1 squiggly mx1 plus b so that you can get the m value and b value to create the equation. Okay? So that's it. That's it for systems of equations, solving and writing system of equations. This is a longer, one of the longer lessons that I have so far. I haven't done the rest yet, so just chunk this into different pieces to, if you're watching the video, to try and get the most out of it, and just to pace yourself and take pauses, take breaks as you're working through this. But otherwise, if you have any questions, let me know. I'll see y'all in the next video.